Let's look at what a surd is. So before we look at the definition of a surd, we first need to think about these 2 points here. So the first point is that an irrational number is a number that cannot be written in the form x over y, where x and y are whole numbers and y doesn't equal to 0. And also, all non-terminating and non-recurring decimals cannot be written as fractions. A surd is a number that involves a root, and a surd is always an irrational number. Let's look at some examples of numbers that are surds and numbers that are not surds. Let's look at the square root of 2. So we're looking for a number that multiplies by itself twice to give us 2 here. And there is no whole number that satisfies that. There is, however, a non-terminating and non-recurring decimal. So if we were to type the square root of 2 into a calculator, we would find we get 1.414213562. So that's on a standard calculator. Now the issue with a standard calculator is that the display is not large enough to show all of the digits in this decimal. In fact, this decimal goes on forever. So the next digits are 3, 7, 3, 0, 9, 5, 0, and so on. So this is an example of a non-terminating decimal. In other words, it doesn't end, it goes on forever. And a non-recurring decimal. In other words, there's no repetition within the digits, they're just a random arrangement of digits. And so therefore, we can say that the square root of 2 is a surd, since we said that all non-terminating and non-recurring decimals cannot be written as fractions, and so therefore they must be irrational. And by the definition of a surd is a number that involves a root, so we have the square root here, and a surd is always an irrational number, and this number here is irrational. Likewise, if we have the square root of 3, this is also a surd, since there's no number that multiplies by itself to give us 3 other than a non-terminating and non-recurring decimal. If we were to put this on a calculator, we would find we get 1.732050808, and so on. And so this decimal is non-terminating, goes on forever, and it's non-recurring, and so therefore it can't be written as a fraction. And so the square root of 3 is a surd. Another example of a surd would be the square root of 29. So 29 is a prime number. The square root of 29 results in a surd. Any prime number, if we take the square root of it, it will always result in a surd. In fact, any number that's not a perfect square, if we take the square root of it, it will result in a surd. So for instance, the square root of 40. 40 is not a perfect square. There's no whole number that times itself twice to give us 40, and so the square root of 40 is a surd. Examples of numbers that are not surds. So for instance, if we had the square root of 4, we're looking for a number that multiplies by itself twice to give us 4, and that number is 2, since 2 times 2 gives us 4. 2 we can write as a fraction. That's the same as 2 over 1, or 4 over 2, or 3 over 6, or any other equivalent form, and so therefore the square root of 4 is not a surd. The square root of 25 is also not a surd, since we have 5 times 5, which gives us 25, and so the square root of 25 is 5, and 5 can be written as a fraction in the following way, so 5 over 1, 10 over 2, or any other equivalent form. And so in summary, the square root of any perfect square, so that's any number that is a perfect square, so for instance, the square root of 100 will always result in a whole number, and so therefore the square root of that perfect square will not be a surd. And so in this example, the square root of 100 is equal to 10. The square root of 16, for example, 16 is a perfect square, is equal to 4. The square root of 81 is equal to 9, and so on. Likewise, we can also have a combination of perfect squares within a fraction. So for instance, if we have the square root of 4 over 25, then this is not a surd, since this simplifies to 2 over 5, and 2 over 5 is a fraction. Could also have the square root of 1 over 9, and 1 over 9 can be simplified to 1 over 3. And so since this is a fraction, the square root of 1 over 9 is also not a surd. We don't just have to have square roots, we can also have cube roots. So the cube root of 7, for instance, is a surd, since there's no number that multiplies by itself 3 times to give us 7 other than a non-terminating, non-recurring decimal. If we were to put this in a calculator, we would find we end up with 1.9129331183, and so on. And so this is an example of a non-terminating, non-recurring decimal. It's the cube root of 7 is a surd. Another example would be the cube root of 100. And in essence, if we were to generalize this, the cube root of any number that is not a perfect cube will end up being a surd. Some examples of numbers that are not surds now that involve cube roots. So for instance, if we had the cube root of 8, we're looking for a number that times itself 3 times to give us 8, and that number is 2. And 2 can be written as a fraction in the following ways: 2 over 1 or any other equivalent form. Likewise, if we have the cube root of 64, the cube root of 64 is equal to 4. 4 times 4 is 16, times 4 is 64. And so 4 can also be written as a fraction, as 4 over 1, and so therefore it's not a surd. So sometimes we can also have decimals. So let's take the square root of 0.23. Then this is a surd since we've got a decimal here, and first we would need to write this as a fraction. So 0.23 can be written as 23 over 100. So the square root of 0.23 is the same as the square root of 23 over 100. However, within this fraction, we have a number that is not a perfect square. And if we were to take the square root of that number, we would end up with a surd. If we had the square root of 0.16, then this is not a surd, since 0.16 can be written as 16 over 100. And so if we take the square root of 16 over 100, we're looking for a number that multiplies by itself to give us 16 over 100. And that number is 4 over 10. And 4 over 10 is a fraction, and so therefore it is not a surd. Other numbers that are not surds are pi, for instance, which is an example of a non-terminating and non-recurring decimal, and so it cannot be written as a fraction. However, the definition of a surd is that it's a number that involves a root, and pi does not involve any roots. So if we were to write pi in decimal form, we would write it as 3.141592654, and so on. And we see that this is an example of a non-terminating, non-recurring decimal. So it can't be written as a fraction, but again, a surd always involves a root, and there are no roots involved here. Likewise, if we have the square root of 0, square root of 0 is equal to 0, and 0 can be written as a fraction, so 0 over 1 or 0 over 2, and so on. And so this is not a surd. Square root of 1, again, can be written as 1. Since 1 can be written as a fraction, then it is not a surd. And in fact, if we took any positive root of 0 or any positive root of 1, so for instance the cube root, the fourth root, the fifth root, and so on, any root of 0 that's positive would end up being 0, and any root of 1 that's positive would end up being 1. And so we see that we can make generalizations in terms of types of numbers, and whether if we take the root of those numbers, we end up with surds, or whether we end up with numbers that are not surds.